These are notes on types of measurement. So here's where you're going to learn about like liters and meters and grams and even other things. I'm going to teach you the tools you use and the units that are used and maybe different options for the same measurement, so that then when I say something like go get the beaker and put in 20 milliliters of oil, you know exactly what I'm talking about and how to do that. So the first thing is measuring distance. And distance, I think we all know, but it's how long something is. It's the size between 2 points. And distance actually uses a lot of words. So you might see distance, you might see length. What's the length of a whiteboard? You might see width, like what's the width of a box? You might see height, like what's the height of the room? But all of these are really distance. So you measure them the exact same way with the same tools and the same units. So the main tool you use to measure distance is a ruler. And this ruler has two different units. So it's got these small ones here, and that's hard to see, plus it's upside down, but that's centimeters. And then on this side is inches. So you can see 12 inches, which is a foot, equals about 30.5 centimeters. So that's the exact same measurement. And in science, we're generally going to use the centimeter side. We also have a meter stick. A meter stick is almost exactly the same thing, except it's a lot longer. So like if I want to measure something small, I probably don't want to have a meter stick out. But if I want to measure something large, it might be harder to use a ruler. So I would choose my tool that way. And you can see the ruler goes up to, as we said, like 30.5 centimeters. The meter stick goes up to 100 centimeters. So 100 centimeters equals 1 meter. You can even write that down. 100 centimeters is 1 meter. It's the same measurement. And then the units we use, depending on what we're measuring, are meters, which is abbreviated as M, centimeters, which is cm, and millimeters, which is mm. And we already know that 100 centimeters equals a meter. Well, 1,000 millimeters equals a meter, or 10 millimeters equals a centimeter. So each of these itty-bitty marks in between the numbers, that's a millimeter. And so it depends what you're measuring. If you're measuring like a hole punch in a piece of paper, you'd probably use millimeters. If you're measuring the length of the room, you'd probably use meters, just because it's easier that way. So then we have measuring volume. Volume is how much space something takes up. So the tools used to measure volume are a beaker, so that's the one that looks like a cup. A graduated cylinder, that's the one nobody knew what it was called. And a flask, that's the one that kind of looks like a beaker but is narrower at the top. And you can use any of these. They have their pluses and minuses. So a beaker holds a lot more. Like you can see, this beaker holds 300 milliliters. This flask, I mean, if you have a big enough flask, this holds 1,000 milliliters. The graduated cylinder only holds 100, but the graduated cylinder is a lot more accurate. So if you notice, this goes up by tens, and there's even lines in between. Whereas here, this goes up 50, 100, 150, so you have to do some estimating. The units are liters and milliliters. If you think of like a 2-liter bottle of soda, right, that's 2 liters. A lot of water bottles are 1 liter. But really, in science, most of the time, we use much less than a liter, so we use milliliters. And just like 1,000 millimeters was a liter, 1,000 milliliters is a liter. So milli means 1,000. So that's how you can remember that. So then measuring mass. Mass is the total number of particles in something. And a lot of people confuse mass and weight. because here on Earth it's the same thing, but actually what's interesting is in outer space it would be different. Your mass would be the same, but because gravity is different, your weight would be different. So like on the moon you would weigh a lot less, but you didn't actually lose any like you didn't really lose weight going to the moon. Well, you lost weight, but you didn't lose mass, so you're not going to look any different. So for measuring mass, the tools we use, there's two of them. One is a scale and one is a balance. So here at JAMS, we just use scales, and it's pretty easy to use. You turn it on, you put something on top, tells you the mass of something, but you can also use a balance where what you would do is you would move all these little things until the whole thing balanced out. That's why it's called a balance. And the units we use are grams, kilograms, and milligrams. So hopefully you remember from before, milligrams is 1,000, so there are 1,000 milligrams in 1 gram. There's actually 1,000 grams in 1 kilogram. So like we can draw some arrows here, and we can say 1,000. It's not easy for me to write with the mouse I have, but doing my best. And then 1,000 here. And I would say in science we generally use grams. Sometimes if we're measuring something really small, we might use milligrams. If you have like a bottle of Tylenol or aspirin at home, it's going to say generally each pill is 200 mg. That's 200 milligrams because that's really small. If you were measuring your weight, like in the United States we use pounds, but in pretty much every other country they use kilograms, and so they'll say kilos. So my cousins live in Europe, they would say I weigh this many kilos, and that stands for kilograms. But generally in science we're going to use grams. And finally, measuring temperature. So temperature is the average amount of heat that the particles have. It has to do with how much the particles are moving. If the particles are moving more, that thing is going to be hotter. If the particles are moving less, that thing is going to be colder. And we'll talk about that a little later in the year. Temperature is a thermometer, and I think everybody was really clear on the thermometer and what it does. So the units are degrees Celsius and Kelvin. There's also Fahrenheit, but we don't use that one in science. Most of the time we use degrees Celsius, so this is the little degrees sign, and then a capital C for Celsius. Sometimes if you're measuring things that are really, really hot, like stars often, the temperature of stars, you use Kelvin. And what's interesting about Kelvin is that it doesn't use a degrees sign, so that's kind of neat. So please make sure you write down any questions you have so that you can ask them and get help with it. And now you'll be ready to move on to the tools of measurement activity where you use all of these things. Have a good day.